Hi, we are on chapter 5. In this video lecture, I will solve problem 8 of chapter 5. The statement of the problem: a cockroach crawls with constant speed in a circular path of radius b on a phonograph turntable rotating with constant angular speed omega. The circular path is concentric with the center of the turntable. If the mass of the inset is m and the coefficient of static friction with the surface of the turntable is us, how fast relative to the turntable can the cockroach crawl before it starts to slip? If it goes in the direction of rotation, so this is part A, and if it goes opposite to the direction of rotation, this is the part B of this problem. So a cockroach crawls with constant speed, it is mentioned in the problem, in a circular path of radius b on a phonograph turntable rotating with constant angular speed omega. So this angular speed, it is constant, and yeah, so the speed of the cockroach, it is also constant. The mass of the insect, it is m. Coefficient of static friction, it is us. And before the cockroach starts to slip, this is the condition. In that case, f is less than equal to us mg, and this f, it is equal to ma, which is less than equal to us mg. And this is a simplification. We cancel this m with this m, and finally we get this equation. This is equation 1. So using equation 5.2.14 in your textbook of analytical mechanics, you can see this equation. This is the equation, which is 5.2.14. So using this equation, we can calculate A for the cockroach. But before calculating this A, we need to find, there are several terms that we need to find, like this one and this one, this r dash, this a naught. So in the coming part, we have to find these terms. The rotational acceleration of cockroach relative to the table is a dash, like this is a dash. So this rotational acceleration of cockroach relative to the table, it is equal to v dash square over b into minus r unit vector, r dash unit vector. So this is equation 3. The direction of the constant angular speed is out of plane of the table. So this is the constant angular speed. So if we take here, in this equation, in equation 2, you can see that we need omega dot. So it means we need to take the derivative of equation 4. But because this omega is constant, equation 4, it is 0. Because when we take the derivative of constant, it is always 0. So let r dash, this is the second term, let r dash be the radius of the table. So the equation is that r dash is equal to b r dash unit vector. This b, it is mentioned in the problem that this b is the radius. So assuming that the velocity of the cockroach is v, which is in direction of rotating table. So then v dash, it is equal to v dash theta dash unit vector. This is equation number 6. So as a naught is equal to 0, because the center of the table is fixed, it is also mentioned in the problem, the center of the table is fixed, so a naught is 0. So in the first part of the problem, we have to find how fast the cockroach crawls in the direction of rotation before it slips. So plugging the value in equation 2, this is the equation 2, which was also mentioned in the previous slide. So there are two ways. First, we have the values of these terms, like this one and this one, this one, and this one, omega dot and a. So simply we can put all the values in equation 1 at one time, but here I will put these values one by one, just for your understanding. So in the first I will put a naught, which is equal to 0. So I just, if we put the a naught value of a naught here, you can see, so this term is 0 now, and then we will put the value of a dash, which is equal to v dash square over b into minus r dash unit vector. Sorry. So here we just replace the a dash with its value, and then remaining all other terms, these are the same. Sorry. And then we have calculated that the derivative of the constant angular speed, it is 0. So when we put this value here, so this term becomes 0. Then, like, we will put that we will replace this omega with here actually we replace the omega with omega k unit vector, and then velocity, here we replaced the velocity with the term v dash theta dash unit vector. Actually this is theta dash unit vector. So here we will just do the cross multiplication, and we will get the relation like a is equal to v dash square over b minus r dash unit vector plus 2 omega v dash into minus r dash unit vector. Actually it is we did the cross multiplication here, and then plus omega into omega cross r dash. So this is not the unit vector. So with the simplification, we will get the relation a is equal to minus v dash square over b r dash unit vector. This minus is outside now, and then again this minus is outside now, and we have minus 2 omega v dash r dash unit vector plus omega in cross omega cross r dash. So we also have other term like radius r dash, it is equal to b r dash unit vector. We will just replace this radius r dash with the term b r dash unit vector. So we replace in this equation, like in this equation, a is equal to v dash square over b r dash unit vector minus 2 omega v dash r dash unit vector plus omega cross b r dash unit vector. So in this relation we only replace this term with r, we replaced r dash with this term b r dash unit vector. So here we will again do cross multiplication, and we will get this relation like a is equal to minus v dash square over b r dash unit vector minus 2 omega v dash r dash unit vector plus omega cross vb theta dash. Sorry. And we know that this omega is equal to omega k unit vector. So simply we will replace this omega. So the final the next relation is A is equal to minus v dash square over b r dash unit vector minus 2 omega v dash r dash unit vector plus omega k unit vector cross omega b theta unit vector. So again we will do cross multiplication. So the relation is A is equal to relation after the cross multiplication. It is A is equal to minus v dash square over b r dash unit vector minus 2 omega v dash r dash unit vector plus omega square b into minus r dash unit vector. So if you follow the previous equations, actually I cannot go into the previous slide, so you will see that finally we get this relation. Then A is equal to minus v dash v square v dash square over b into r dash unit vector minus 2 omega v dash r dash unit vector minus omega square b r dash unit vector. So this minus is now it is outside. So with simplification, the relation is A is equal to minus v dash square over b plus 2 omega v dash plus omega square b into r dash unit vector. So this r dash, it is common in the above relation, as you see. So we just took this out and we get the equation 7. So from equation 1, this is the equation 1. In this equation 1 we will just put the value of a here. So this is the value of a, which is less than equal to USG. So here we will again do simplification. This minus is removed because of the mod, and then we will multiply this relation with we will multiply this this relation with b, because this b is in the denominator. So v dash square plus 2 omega b v dash plus omega square b square less than equal to us gb v square. So this is just simplification. We took this term on the left hand side. So v square plus 2 omega b v dash plus omega square b square minus us gb less than equal to 0. So for maximum velocity v maximum, so the relation is v maximum dash square plus 2vb v 2 omega b v maximum dash plus omega square b square minus us gb equal to 0. Can you wait please? Yeah, so we are on the on this relation. So this is the quadratic equation actually. So here this v max dash it is equal to minus 2 omega b plus minus 2 omega b square minus 4 into omega square b square minus us gb, and then under root of this complete term, like under root of this term over 2. So after simplification we get that v max dash it is equal to minus omega b plus minus omega square b square minus omega square b square plus us gb square root. So these two terms are the same, but they have opposite charges, so we will just cancel these two terms. And finally our v max it is equal to minus omega p plus minus square root USGB. So this is about the first part of the problem. So this is the velocity of the cockroach. In the second part of the problem, we have to find how fast the cockroach crawls in opposite direction of rotating table. So the previous relation, it was about in the direction of rotating table, but here we have to consider the case in which the cockroach crawls in opposite direction of the rotating table. So because it is opposite, so simply in this case this v dash, it should be equal to minus v dash theta dash unit vector. So we will plug this equation into equation 7, which is a is equal to minus mu dash square over b plus 2 omega into minus v dash plus omega square b into r dash unit vector. So here we took this minus outside, and this is the relation, and from equation 1, this is equation 1, we will here, this is the value of a, so we will put this value a here. So the term is that the minus v dash square over b minus 2 omega v dash plus omega square b into r dash unit vector. The mart, this is the mart, which is less than equal to u. So with simplification, as we did in the previous part A, so we will follow the same calculation, and when we take this term on the left hand side, we get the relation v dash square minus 2 omega b v dash plus omega square v square minus us gb, which is less than equal to 0. So for maximum velocity, v maximum minus 2 omega b v maximum dash plus omega square b square minus us gb equal to 0. So this is kind of quadratic equation, so we will just apply the formula, and after that we have this relation. With the simplification, we get v maximum dash v max dash, which is equal to omega b plus minus omega square b square minus omega square b square us gb. So these two terms are the same with opposite signs, so we will cancel them, and you can see the difference of this equation with the previous equation. Like this equation, what is the difference? Difference is only this part, because there is no sign. Actually this is the positive sign, but in the previous relation there was negative sign. So finally this maximum velocity, it is equal to, before the cockroach slips, this is the velocity, it is equal to minus omega b plus minus square root of us gb. So this is about the velocity in the opposite direction. So this was all about the problem 5.8. Thank you.